Hey guys, welcome to your next lesson. This is going to cover basically what we did the previous lesson, but now what we're going to do is we're going to apply what we know about angles and use that information to help us solve problems. Angle problems, basically. Problems where there are angles that are missing. Okay, now here's your first example right here. We're going to look at complementary angles. Before we start solving here for x, we're going to look at this and think about, okay, what is it about this diagram, this picture, that tells us that we're dealing with complementary angles. And one dead giveaway is the box in the corner here. Okay, so what we have is the universal symbol for a right angle, which is a box. That indicates that this entire angle, this angle right here, is equal to 90 degrees. That's what complementary means. Okay, complementary, two angles that add up to 90 degrees. You can also say the same thing about this angle that does not have a box in it, but you can assume that that's 90 as well, because 90 and 90 makes 180. Okay, now that we know that the box helps us understand whether it's a right angle or not, that's pretty much all we need to know in order to figure out what x is. And like I stated before, this entire angle is 90 degrees, so we need to figure out what x is. So if we were to set up an equation, what we would do is we would do x plus 63 equals 90 degrees. And how would we solve that equation? We would just solve that by subtracting 63 from both sides. So we're kind of using our information about how to solve equations to help us figure out this angle problem. And then 90 minus 63, 27 degrees. So that's what x is right there. We know that x is equal to 27 degrees. So to kind of recap what we just did there, x was the angle we're looking for. We knew that this angle was 63. We know that the sum of those two angles is equal to 90. So we set up a basic equation to help us solve that. Now I know what you're thinking, why can't I just do 90 minus 3? And I agree with you, that's how you do it. But be prepared to show us the equation as well. Be prepared for that. I want you guys to be able to show proof that you understand how to set up and solve an equation, a real basic equation like this one, in order to help us figure out what x was. Now in our next example here, what we're going to do is we're going to look at this as supplementary angles. And somehow this picture didn't come out quite as well as I wanted it to. But what we have are supplementary angles, and supplementary angles add up to 180 degrees. Together they make a linear pair. Usually you'll find supplementary angles hanging out on a straight line or a straight angle. And so what we have here is, again, we have another example where we have an unknown, an x, and then another angle that we do know, 156 degrees. So to set this up, again, we're going to set up an equation, x plus 156 degrees equals, and what do supplementary angles add up to? They add up to 180. So there's our basic equation. So like I said, be prepared to set up an equation for these kind of problems. I know you're thinking, I can just do 180 minus 156 and be done with it. But the more you practice this, the better you're going to get at it. So we're going to do minus 156 from both sides. These cancel each other out. You're left with x equals, and whatever 180 minus 156 is, and that comes out to 24 degrees. So x equals 24. And if I want to check that, I'll just, off to the side, add those up. Plus 4 is 10, and 1 plus 5 plus 2 is 8. And then the 1 drops down. So that seems to all work out. 24 and 156 equals 180 degrees. In this next example, what we want to do is we want to apply our knowledge of vertical angles to help us figure this out. There are some other applications to this problem that could help you as well. But let's specifically talk about vertical angles and how that applies to this problem. So what we have is the given right here. My eyes instantly go to the number that's given, and that's 57 degrees. Now I'm not going to get out my protractor and measure this angle. All we need is what we see in terms of what's given in this problem. So we don't need to get a protractor out and start measuring. We have all the information we need in front of us to solve all the angles that we can't see. We can figure out this angle, we know what this angle is, we know what this angle is, all without a protractor. And it's all because we know that that's 57 degrees and that we know that these are intersecting lines. So there's a lot of information there. Okay, so this angle right here, like I said, is 57 degrees. Now vertical angles are angles that are opposite of one another. So 57 degrees is opposite of this angle right here. Okay, now the angle that's 57 degrees, let me just kind of describe this to you. When we write down what an angle is, we use the angle symbol. That's the symbol for an angle. Whether it's acute or obtuse, we always use that symbol. And then we denote the angle by using the three letters that make up the angle. The middle letter, D, has to be the vertex. So what we're going to do is we're going to write this as angle AD. So angle ADB equals 57 degrees. And then the angle that's vertical from it, this angle right here, we can call that angle HD. And what we know about vertical angles is that they're equal. So this is also going to be 57 degrees. So that's 57 right there. Okay, now that we know that that's 57 degrees, we can figure out this angle too, without a protractor of any kind. All we need is what we know about angles. Now if you look really closely at this angle right here and this angle right here are both on a straight line. Okay, a line segment really, but they're on a straight line, which makes them a linear pair. Now linear pairs are supplementary. They equal 180 degrees. So knowing that, we can figure out what this angle is. I'm just going to call that n. And so now what you have is n plus 57 is 180 degrees. And we know that those angles make up a linear pair, which means they are supplementary, and now it's just a matter of solving the equation for n. So to solve this equation, we're going to take away 57 degrees from both sides. These cancel off. Those are called the additive inverse. N equals the difference of 180 minus 57, and the answer comes out to 123 degrees. So right there, that angle, call that angle BDT. B, the vertex is in the middle. D, the letter that is the vertex is D, and then T. We can say that BDT equals 123 degrees. And then that makes it really, really easy to figure out the angle that's across from it right here. This angle right there, we'll call that angle ADH. Angle ADH is also 123 degrees. So there you go. I mean, all we were given at the very start of this problem was this angle right here was 57 degrees, and that was just enough information to figure out the angle that was across from it and the angle that it was adjacent to. That's it. We pretty much know what all the angles are. In this example, what we're going to do is we're going to look at corresponding angle. From the previous lesson, we talked about corresponding angles being angles that have the same position. Now, another thing that you might notice about this problem, and you can't always assume it, but a lot of times it will be stated in the problem. One thing that you can assume with this problem is that these lines, these segments right here, are parallel to each other. And if you remember correctly, if you have parallel lines intersected by a transversal, it's called the transversal, the line that cuts through it, it's really not going to be required that you remember that, but I might use that word again, so I'm just going to throw that out there. Transversal. If you have parallel lines, these two lines are parallel, then corresponding angles will be equal. We call that congruent. Congruent means equal. And 112 degrees corresponds with this angle right here. And it's basically in the same spot, kind of a carbon copy of the previous angle right there. It's to the left of this line. So these are in the same spot. So if these are corresponding, that means this is also 112 degrees. Corresponding angles are equal. They are congruent. So we can state for a fact that angle HCT is also 112 degrees. Now from there, that kind of gets the ball rolling with a lot of other information. We can figure out a lot of other stuff. We know that vertical angles are also going to be equal to 112, and so these two angles right here are vertical. That makes this 112. This angle right here is also 112. So we can say right here, angle MAG equals 112 based on what we know about vertical angles. Same thing right here. This is angle RCA right there. Now hopefully you're noticing what I'm doing here. When I name an angle, when we name angles, we name them by the names of the rays, the vertex, and the other ray. Okay, the letter that's the vertex always has to be in the middle. Angle RCA equals 112 degrees. And then from there, we can figure out other angles. So from there, we can figure out what this angle is right here. Now, how is that angle right here related to this angle right here? And you might be telling yourself, they are a linear pair. They are made up of this line right here. And I'm getting kind of messy, but that's how geometry gets sometimes. But those are definitely a linear pair. They are supplementary to each other. Call this x. So all you have to do now is just set up an equation. X plus 112 equals 180 degrees. We're going to take 112 away from both sides, and then you get x equals the difference of 180 minus 112. So that equals 68 degrees. Angle TCA equals 68 degrees. Alright, and that is also vertical from this angle right here. So angle HCR equals 68 degrees. So look at this. This is kind of messy. That's how math is sometimes. It just shows me that you're thinking and really trying hard and working at this. But sometimes these can be kind of messy. You know, show your work, show your notes, and there's nothing wrong with that. As long as you're doing the arithmetic the right way and thinking the right way, that's good enough for me. And So now we basically have everything we need. This group of angles right here is no different from this group of angles over here. This was 68 degrees, well, so is this. So that's, like I said, it's kind of a carbon copy of the angles from one side to another. Okay, in this example, what we want to basically do is we want to figure out all the missing angles. Okay, we want to find out all the angles that are not given. And in this problem, all we're given is that this angle right here is 24, and a little bit indirectly, we know that this angle right here is 90 degrees. Okay, so I'm going to write down what we know so far. We know that angle CFD equals 24 degrees, and we also know that angle BFD equals 90. What else do we want to find? Well, we want to find this angle right here. That's angle DFE. We want to know what that is, and we want to know what this angle is right here. We'll call that angle AFE, and we want to know this large obtuse angle as well. So that's going to be called angle AB. Okay, so where do we start? That's usually a good question, and a very common question when you're doing problems like this is, where do you start? There's a lot of missing information. There's a lot of missing angles, I should really say. It may seem like you don't have enough, but you do. Okay, so let's start in this region of this figure right here. Okay, we know that this is 24 degrees right here, and we know that this entire angle is 90 degrees. So based on that information, we can probably figure out what this angle is right there. Okay, together, those are complementary. Complementary means 90 degrees. So we have x plus 24 equals 90 degrees. Take away 24 from both sides, inverse operation, and then you get x equals 66 degrees. Okay, so there we go. We just figured out one angle. We just figured out that BFC is equal to 66 degrees. Okay, so I'm going to write that in there, degrees. Now, one thing that you might also notice is that right here, this angle, and kind of color that in, this angle right here and this angle right here are what you would consider what? Starts with a V. Those are called vertical angles. Those are vertical. And since they're vertical, you know that they are equal. So that makes this one 6 degrees. Very easy if you can identify those kind of things in geometry. So AFE is 66 degrees as well. Next, let's go on to here and find that angle, BFA or AFB. I should also mention that it doesn't matter the order in which you write those angles. What I'm basically saying is, as long as you have the F in the middle, but you can call that angle AFB or angle BFA. It doesn't matter, okay? Now I went ahead and kind of erased this, cleared off the screen here because it was getting a little bit too messy for my taste. And right here, we're going to find this angle. Now one thing that might not pop out at you right away is the fact that these angles right here, these two angles are part of a linear pair. They lie on this line right there, which means that it's part of a straight angle, and straight angles equal 180 degrees. Call this x. We know that this angle and this angle make 180. So I'm just going to set up my equation. X plus 66 equals 180 degrees. Now to solve that, we're just going to take 66 away from both sides of the equation, and you get x equals 114 degrees. We'll call that angle AFB. That equals 114 degrees. That leaves us one more angle, which is right here. And if you notice, it's right next to a right angle. It's right next to a right angle, and it's a linear pair that lies on this straight angle right there. So if it's right next to a right angle, this is n, that means that together, n plus 90 better equal 180. You take away 90 from both sides, and guess what? You're stuck with 90 again, and you're finished. So that angle right there is 90 degrees. So putting it all together here, we know that angle BFC, this angle right here, we knew that that was 66 degrees. This was already given. Angle CFD was 24 degrees. This right here we determined was 90 degrees, called angle DFE. This angle right here was vertical from this angle, which made it 66 degrees. So angle AFE equals 66 degrees. And then this angle right here, we determined was a linear pair with 66 degrees. And that's called angle AFB. And that came out to 114 degrees. And that's pretty much it. So that was about as tough as it gets with these kind of problems. But, if you're persistent, keep working on these, you're going to get it. Just kind of start with the easiest parts of the angles, the things that you can find out first, and then kind of like a domino effect. Just keep solving it and working it out, and things will kind of come together at the very end. It may seem like a little bit much at the beginning, but like I said, just be persistent, keep working at it, you'll get it. It's not that hard, but it definitely takes some practice. Okay, everybody, that does it for my examples. We're going to be working on this tomorrow, so make sure you guys took notes and be prepared to do these same kind of problems on your target practice the next day. And we'll be working hard on these and making sure we all understand them. Everyone, have a great night. I'll see you tomorrow. Take care.